Teaching through problem solving promote mathematical practice. Area number 3. After the grade 3 area formula is introduced, and grade 4, grade 5 ask students to apply their knowledge for finding area of rectangle and square to find problems, and then they extend this one to value of the shapes. And in grade 6, the solve real-world mathematical problem involving area, surface area, and then volume. And then number 1, find the area of right triangle, other triangles, special quadrilaterals, and then polygons by composing into rectangles or decompose into triangle and then other shapes. Apply those techniques in the context of solving real-world and then mathematical problems. So basically, we want students to use what they have learned in grade 3 to apply this knowledge to find the area of other shapes. Let's see. Look at this problem. The shape of the rectangle ABCD is going to change to a parallelogram. The length of each side will be the same, but the angle of BAC will become smaller. So you could see the original angle was 90 degrees because this is rectangle, but this becomes smaller. With other, like this length, those stay the same. Okay, will the area of the shape be different or stay the same? I need you to think about it. Okay, so now the rectangle will become parallelogram. So we're gonna come back to this. So the grade 6, and as you may know, there is a CCSS, Common Core State Standard Progression Document, which is kind of informal document. However, you can find in the University of Arizona website, and they elaborate a little bit more about what the standard means. So the geometry grade 6, they talked about using the shape, composition, and decomposition skills acquired in the earlier grade. Students learn to develop area formula for parallelogram, then triangles. They learn how to address 3 different cases of triangles: a height that is a side of a right angle, a height that lies over the base, and then height that is outside the triangle. So various triangles we want students to be able to calculate by using area formulas. And basically, we do not want students to draw unit squares inside of the shape and then simply counting to find the area. We want students to apply the formula which they have learned in the grade 3 to calculate the shapes. The Japanese national curriculum, they elaborate a little bit more about this, the more clear expectation in upper grade in area measurement. And they teach, they focus in the grade 5 to help pupils determine the area of geometrical figures by calculation. So they explicitly say calculation. To explore way of determining the area of triangle, parallelogram, rhombuses, and then trapezoid. And the teaching guides say the main objective are to determine how to find the area of triangles, parallelograms, rhombus, and then trapezoid based on the method already learned from determining the area of geometric figures, to explain the method, to create formula, and then to cultivate the ability to think logically in this process. Students are expected to explain how to determine area based on the ideas such as the following. 1. Move a part of the geometric figure and then transform into an already learned shape of equivalent area. So what is the already learned shape? In this case, at this moment, they are the rectangle and square. After they learn parallelogram, they want to use a parallelogram formula to find the various area. So the prior learning, how you apply prior learning to a new situation, is one of the big emphasis. Think about a given shape as half of the area of an already learned geometric figure. Remember, we talked about find the area of this shape previously. And if you add this, so think about a given shape as half of already learned area. Already learned. So already learned shape is rectangle. That's why looking at this L shape as a half of this one, so that you can use that kind of ideas. We want students to use it. Decompose shape into several already learned geometric figures. For example, if you're talking about L shape, you divide into 2. So, decomposing shape. Those are ideas. You want students to use it. So, an example of the Japanese, the grade 5 textbook, they talked about this. So they spend 5 days, 5 lessons, 5 days. Basically, each lesson is about 45 minutes. For parallelogram, another 5 for triangle, 3 lessons for trapezoid, and 3 lessons for other shapes, and then the exercise. That's the unit design. So total 10, 16, 17, 18 lessons. So that means a little more than 3 weeks, almost 1 month, to introducing the area of measurement in the grade 5 in Japanese textbook. In this case, the grade 6 in Common Core State Standard. Spending about a month, the slow pace, but help them to really understand all these conceptual understanding, and then be able to fluently use this to calculate various area. So, and then each lesson is understand the problem, individual group problem solving, whole class discussion, summarize learning. And then you repeat this one 5 days. Let's see how they spend time to help students to really understand the area of parallelogram. So, this is lesson 1. Think about how to find the area of parallelogram. Of course, you can count 1, 2, 3, 4. Oops, it's not the 1. That kind of way to count. This is not something we want students to do this. We want students to use this prior learning, which is area formula for finding the rectangle or square, to use it. How are you going to do this? So teaching through problem solving. Once we want students to think about it. But by the way, what is a typical misconception, misunderstanding about finding area parallelogram? So the student maybe simply apply what they know is area of rectangle. The rectangle, you multiply length of 2 sides, which is this side and this side. Because area of rectangle is multiplied by length and width. So maybe multiply by this and this one and this. And this particular diagram does not give the measurement. However, we want students to have actual size so that they can 1, 2, 3, 4, 5, 6, 7 centimeter. And if students say, I want to know this is very carefully written about. This is a 3, 4, 5. Actually, this slanted side is 5 centimeter. So naturally, the student come up with two different approaches. Maybe like one misunderstanding is 1, 2, 3, 4, 5, 6, 7. 7 times 5 is a kind of misconception that the student might bring. And then some other students say, wait a minute, because this is not a rectangle, we cannot use it. How we could do this? Well, because I do not want to have this triangle part. That makes me difficult because we have not learned yet. So how about this, move this one to here? Now it's become rectangle with 1, 2, 3, 4, 5, 6, 7 times 4. Which is correct? You're gonna have a discussion, debate. Again, developing viable argument and critiquing others. That's the kind of way we want students to have some discussion. And the ideal way is you can cut some way to move this one to make a rectangle. So then the area of parallelogram can be found by changing into rectangle. That's the idea. So in this case, you can cut this shape in here to move it. Or you can cut in the middle. It doesn't matter. However, its important thing is it has to be perpendicular. Why this has to be perpendicular? Because we want to change this shape, parallelogram, into rectangle. Rectangle, the angle has to be perpendicular. So therefore, the perpendicular is very important. So how we call this perpendicular line? We call height. So therefore, we said base times height. Height can be any place as far as this is perpendicular to the base. Therefore, if you look at this is the base, this can be height, but has to be perpendicular. So that's a way to introducing. And we're going to have a lesson 2. This is day 2. Based on the previous day's discussion, we're going to formalize, the formula for finding area of parallelogram. And once you formalizing this the formula, you're going to practice. You're going to apply to this one. So this is a base times height, relatively easy to find it. But how about this? Looks like this is base, but is this base? And then this shape give you 3 measurements. So you have to choose which one is the base, which one is height. So if you really understand this one, this is the base and this is height because this is perpendicular. So we want student to identify which is the base and which is height. So the one of the misconception, the student always say base has to be this because this is base, but it's not. So the base and height, these are relationship. The term is representing relationship, which is different from the everyday vocabulary of base or height. So base, the most important part is the base, and then height is a 2 measurement, which like have a perpendicular. And then this problem you want to measure. You need to figure out. Okay. Also, we want the student to measure by themselves. And if you use this, if you think about everyday life, when you find the area, first things you need is you need to measure necessary place. Nobody give you a measurement. So therefore, this is more like a more application for everyday life. So if you have this shape and try to find how much the area, measurement. So in this case, 3, this is supposed to be perpendicular. But some other students say, I want to try to find this way. So both has to be the same answer. And that is important for exercise, and you could have multiple approaches. It depends on how you look at the shape, and the base can be different. Once students find out this, simply apply this area formula, maybe we're going to challenge them. Okay, so find a way to calculate the area of parallelogram ABCD using BC as a base. If you have a base, where is the height? Okay, if you look at this is base, this is base, height is like this. However, from previous lesson, you could use this one as a base. So in this case, where is height? We need to help a student to, we encourage student to kind of prove, it's still, this base can be calculated when and how you identify your height. Again, we do not want to tell student, but we want the student to come up. And many people say, well, that's too difficult for many students to do this. And I know it's a long time ago, but we tried this approach to the student in the very challenging neighborhood, which is in Patterson, New Jersey. The student is very weak foundation. Many people do not think those students can do it, but those 6th grade students did a good job. We gave this to the student, and they use scissors and then the rulers and cut and move it, and they come up with a variety of solutions. For example, these are all solution methods that the student come up. So the one approach, student cut this shape into 2 like this. Now base times height, and base times height. So you cut into 2 this and then add them all and then find out. So in this case, this is cut into half. The height becomes double of this. Another approach is the student is finding total area, you add these 3 pieces. These pieces make it a big rectangle. If you move this one, it's become like this. So this is going to be the area. So the base times height. It's very simple. You transform this into. Another one is also cut into 2. Another approach. This is very brilliant. If you cut this one using diagram and then move it, the parallelogram stand up. Another one is cut and piece and move it to find out. This student is brilliant. You just simply put them together, make it double. Now height is inside. So the base become double of base times height, divided by 2 because we multiply. So now it's become base times height. So the height is this height. And then they come up with solutions. So even though this kind of shape, you could use this as base, but in this case, height is outside of this. Now, you should be able to find the area of this shape. You need to identify which is base, which is height. Where is the base? Where is height? It shouldn't be the base in this case. If this is base, base should be this. But we do not have this. So in this case, where is the perpendicular? So that's this 2. This is the base. and this is height. So 2 times 4 is 8 square meter. So we want the student to be very, very flexible. If the student simply memorize the base and height and then could not identify where is the base, where is the height, you cannot solve this problem. And there are a lot of, the problem. So even though this is like, the odd place is in height, but students should be able to find very flexibly. Before we go to triangle, we need to look at this. This is a problem we discussed earlier. So what happens if we move a little bit? Do you think area is the same? How about this way? Area same? How about this way? So obviously you see the area is changing. Although the parameter of this shape doesn't change, but it's become flat. So the parallelogram, once this is rectangle 90 degrees, this is 5 times 10, which is 50. However, once it's become parallelogram, area starts changing. For example, let's see, move it. It's going to be different. Area is smaller and smaller and smaller and smaller and smaller. This is another way to help students to see the area and parameter are independent. After we discuss this change, so these are different from previous one. So in this case, the parameter changes because this parameter is obviously much longer than b. However, the height is the same, base is the same, height is the same, therefore ABC area does not change. So it's important for students to see rather than the shape, the different shape, but you see the kind of movement of the shape, the transforming the shape, without changing parameter or without changing base and height, and then how shape and then how area is going to be different. And you could find the kind of problem like this. So what is this? Like, how you find this area of E? Because the height doesn't change, but the base become half, so the area must be the half. That kind of reasoning, we want the student to do this. And then move to triangle. So how we could come up with this triangle? Again, we want student to use area of rectangle, square, or parallelogram. How you could use this? The Common Core State Standard really expects students to derive this formula. The 3 different ways you can explain at least. If you put this triangle, 2 of them, it's become parallelogram. So using a parallelogram formula to find the area of triangles. Another one is this one and this one, same triangle. This is the same triangle, and then put them together, it's become rectangle. So the area is the half of rectangle. So this approach is using rectangle formula. Another one is cutting to do this and move this, the rearranging shape into flattened kind of rectangle. So in this case, base times half of its height. So this is the base times height and then half. Base times height, which is a length of this rectangle, and then into half. This is like a base times half of its height. So you could come up the formula. And then you could formalize it and then summarize this one. Again, you could expect students to be able to use it. Just like a base times height. However, in this case, we want the student to identify which two measurement you want to use it. This one is not necessary. There is height. However, this is perpendicular. So height, one of each side is base, one of it become height, or base and then height. So we want student to be flexible using it. And again, just like a parallelogram, we could ask a student to measure. Be sure to be perpendicular. And then another one, which is height is outside. How can we find this one? There are several different ways, and then you could discuss this one. So basically the same flow of the lesson. Discuss how you use their prior formula to find the area of this shape. And then based on the experience, you can formalize this formula. Once you come up a formula, you can apply and then be able to flexibly. And shape like this. This is very important for students to be able to calculate. Okay, then using the shape, this is so-called trapezoid. Using the shape, composition and decomposition skill acquired through the deriving formula for finding area of parallelogram triangle, which is common core expect. Find at least 3 ways to calculate the area of the trapezoid above. If you can, you may try to derive the formula for finding an area of trapezoid. This is what I want you to try. You can find the worksheet on the D2L site, and you can download and then write down and you approach. And then once you write down, of course you can type. This is a Word document, you can type. But if you are not comfortable writing an equation using Microsoft Word, you can print out and then write down onto your paper and then take a picture to convert this one into the PDF. And I want you to upload your solutions, at least 3 solutions using a formula that you have learned previously. Rectangle, or parallelogram, or triangle, to calculate this shape. And then once you upload, and you will be able to access to the following presentation so that you can use, you can see and then compare your approach and then the approach that we are going to discuss.